Hey everybody, welcome to the intensity and Falloff tutorial. Now, because of physics, light and distance are tied to this thing called the inverse square law. Now, every time I tried to learn the inverse square law or tried to commit it to memory or try to figure out how to use it, it just made my brain hurt. So what I've done here is I've tried to simplify things for you a little bit. But to explain what it is, just so if somebody asks you, you can explain it to them. Basically, if you double the distance between your light and your subject, you get about a quarter of the amount of light falling on your subject at that distance. Conversely, if you have the distance, you get 3/4 more light. So it's really hard to picture in one's head, and I'll demonstrate it for you here in a little bit. But what does it mean in terms of something we can use, in terms of how many stops do we lose when we double the distance, and how many stops do we gain if we have the distance? So let's take a look at that. So what we've got here is I've got a 650 Fresnel. It's shining right in my face, and I am 10 feet away. Now, in most spaces that you're going to be shooting in, like bedrooms, living rooms and stuff, 10 feet is going to be about the furthest away you're going to be able to get that light. So let's just go ahead and take a reading at exactly 10 feet with our Digistix and see what we get. So right here, looking down at 10 feet, I've got 9 1/3. I'm at ISO 200. The 650 is set to full flood. And we got a reading of 9 1/3. I'm not sure if you can see that. What if we move to 20 feet? So I'm going to back up to 20 feet and do the reading again. So I'm just going to follow my tape measure here to 20 feet, which is right here. Point it at the light. And I've got a reading of 7 1/3. So I lost, by doubling the distance, I lost 2 stops. Now, is that going to happen in every case? No, it's actually going to change a little bit, but it's going to fluctuate between losing a stop and 2/3 to losing 2 stops when you double the distance between 10 feet to 20 feet. So what does that mean in terms of like exposure and such? Well, it depends on really what you want to do with your lens. If your lens, if you wanted like a really shallow depth of field, if you want like a 2.8 or a 2, you're going to want to get your EVs down to about 7 2/3 to 8 2/3. That's going to be right in that range between f2, f2.8. If you go to 1.4, we'll talk about this more when we talk about lenses, but the edges of your lens are going to get really, really soft. All of the 1.4s tend to get kind of fuzzy when you get further out towards the edge of the frame. So 7 2/3 to 8 2/3. Well, right here at 10 feet, I'm at 9 2/3. How do I get down to 8 2/3? I've got to lose 2/3 of a stop to get to 8 2/3 to get to 2.8, which is where I want to be. Well, I got to knock that light down somehow. But you can play Battleship and sit there with scrims and just go, no, that's not good. No, that's not good. You know, it's like you're sitting there just going B4 miss. You know, I call it playing Battleship because you're just shooting in the dark. You don't know what you're doing. But I'm going to grab some scrims here and I'm going to show you that if you have a clean scrim, in this case, which I've got a bunch of stuff laid out here, all kind of junky looking, but I've got these are 2 pretty pristine scrims. These came with my my 2Ks. And you can see the shadows that they make on the ground. If I hold these up, you can see that the double makes a darker shadow than the single. And you want to make sure that your scrims are clean, because if they're rusty or if they're dirty or if they've been burnt, you're not going to get an accurate measurement from them. But this is assuming that you've got clean scrims from like a rental house, or you took really good care of yours. And with a single scrim, you should lose 1/3 of a stop of light. A double scrim should knock it down by a full stop. If you've got like a dirty, I've got a dirty one over here actually, and we can even look at these side by side, and you can see that I've got a rusty, dirty single, which should only be knocking down the light by about 1/3. But this is knocking it down by 1/3, and you can actually see. I'm not sure if you're making it out because it is going to be compressed on the line. But you can see that this scrim is making a darker shadow than this scrim. This one's knocking it down by 1/3. This is about 2/3. So in this particular case, to get where I wanted to go, I could actually put this in. But in a normal situation, And you're going to want to test your own gear. If you're using your gear a lot, I could put 2 singles in, and that'll knock it down by 2/3. That'll get me where I want to be. And just to prove that, it doesn't matter where in the chain I put this. It doesn't matter if I put it up here close to the light, or if I put it right where I'm taking my reading. It doesn't change. If I go here, get 9 1/3, which is what we had before, put the scrim in front of it, knocked it down to 9. Exactly 1/3 of the stop. Same thing here. If we take our double scrim and got 9 1/3, and put the scrim in front of it, and it knocked it down. Oops, I angled it. You're not supposed to angle it. 8 1/3. Knocked it down by exactly 1 stop. If you angle it, you actually change the shadow. Like if you see if I go like that, I don't know if you can see. If you angle the scrim, see how much darker the shadow gets? So you want to make sure, when you're putting a scrim in a light, you're usually just going to dump it right in the slot for the light, which will hold it parallel to the light, which means you'll get a perfect 1 stop. So 1 stop will get me kind of where I want to go, and then I can just move a little bit closer. So if I want to go to that perfect 7 2/3 or 8 2/3 that I wanted to be, I can move in a little bit, and there, I'm at 8 2/3. So that's essentially moving my light a little bit closer, dropping in a double scrim, which reduces the light by 1 stop, and then moving slightly closer gets me to 8 2/3. I've got a perfect 2.8. I can use that, and I'm good to go for at least for my key light. This is just talking about 1 single light. We're not getting into the complexities of all your different lights at once. This is just trying to make things simple so that you can understand kind of ahead of time what lights you're going to need. This is a 650. It's different with a 1K and a 2K. I've tested it with my lights, and I'll post that on the website for you guys to see. But there's other things. What about diffusion? What if you're shooting in hard light and I don't like that hard light. I want to soften it up. But how much am I going to lose? Well, let's find out. I've got a 216 gel here. This is, you can see it's a little dirty, but 216 and 250 are like your 2 standard kind of common gels that you would use. And again, it doesn't matter if I put this up on the light or if I put it later in the chain, it's still going to give me the same reading. So if I'm at 10 feet again, I've got 9 2/3, and I stick this in front of it and take a reading. I lose a stop and a third. And that will never change. If I use a 216 or a 250, I will always lose a stop and a third worth of light off of my hard light. The same thing goes with CTB gels. CTB gels, steel blue. I like steel blue myself. I've got one right here. The exact same thing will happen. If I take my reading here, 10 feet, 9 1/3, then I put my blue gel in front of it, 8. So I lost exactly a stop and a third. And that is helpful if you're thinking, okay, I'm going to be shooting a night scene, so everything's got to be blue. I'm going to, let's say I'm going to put some big lights outside my window. I'm going to take some 2Ks or a 1K, and I'm going to stick them outside the window. And at, let's say, 20 feet, they're going to give, well, I've actually got a cheat sheet here on my phone, so let me find out exactly. A 2K at 20 feet is going to give me a reading of 9 EVs, which is exactly what I'm getting here at 10 feet from the 650. But that means I can put that light outside my window, and here inside the house at about 20 feet away, which will give me some nice shadows and stuff, I will get the same reading that I would have got with a 650 at 10 feet. I'm still at 9, so I'm still in pretty good shape in terms of actual exposure. But what if I put a blue gel in front of that? Well, I'm going to lose a stop and a third. So now I'm going to go from 9 down to 7 2/3. So I'm going to have to open up to, what is that, F2? Yeah, F2. So I'm going to have to open up to F2. If I don't have a lens that fast, or if that's too shallow a depth of field for my purposes, then I'm going to need more light. I'm either going to need to move the light closer, or I'm going to need to change the distance between, move the light closer, or get a faster lens, or bump up my ISO. If you bump up your ISO, right now we're at ISO 200. If I bumped it up to, say, 400, I'm going to gain a stop. And we covered that in another lesson, and you can use those same calculations to figure your stuff out. But anyway, I will put this cheat sheet up. On the cheat sheet, it shows me what I lose, what I gain If I change the light from flood to spot, it shows me what a single scrim will give me, how much light I will take off. Shows me what a double, you're you're losing one stop, and you're adding another one, so you're going to lose two stops. So if your light's way too bright, let's say we're really close like this, and I'm blowing out like I probably am right now on this camera, and I wanted to knock it down by two stops, I just take two double scrims, pop them in the light, boom, I know I'm going to lose exactly two stops. It's going to be perfect. It's going to be great. And then how much you lose with a diffusion gel, 250 and a 216, and how much you're going to lose with your blue gels. And those are the most common ones that you're going to run into. If you're going to soften up your light, if you're going to use blue light, if they're trying to match stuff with the daytime. I can't tell you how many situations I've been in where you're in a house, you're shooting daylight, you've got sunlight coming in through the windows, and you've got 2Ks in the room, and then now you're losing a stop, boom, because you put a blue gel on to match to color match the blue light coming in through the window. And now you put diffusion in front of it. Now you're losing another stop and a third. So now you've lost 2 1/3 stops off the light that you have, and now you've got a 2K in the room, probably about 15 feet away, and you still don't have enough light to light your scene, or you're not getting enough fill, or whatever you're using that light for. So these are calculations, and then so we'll go on the computer now and take a look at some of that and kind of start showing you how to apply this in different situations. I want to thank Collier Landry for coming down and shooting this. He's a fellow gearhead, just like you guys, also a friend of mine. And so thanks to Collier. Check him out online and check out his projects. He's a cool guy. I like him a lot, and I really appreciate him coming down and helping me out with this little tutorial here.